Okay, so Nick just turned on the tough pad, and this is what happens after you do all of the cart assembly that we showed you previously. And the nice part about this software is it'll automatically pop up as soon as you turn the tablet on, and then you'll be ready to collect. So you just be patient and you see the screen pop up here, and then once this green button highlights, then Nick's going to press collect. And in this case, you want to make sure that you have the correct serial numbers pop up, and we have 303, 305, and 312. Press next, and we're going to actually create a new project. So Nick just pressed new project. We had previously set up the project group corresponding to our SP number for this project, and now Nick's going to go through the process of setting up a new project name. So he's putting the month, day, and year for the project name, and he actually had already created this morning, and we made him recreate a new one for the video purpose. So we're going to actually have him append underscore video or dash video here for the project name. Now for the location, we're putting our current county, which is Le Sueur. And this will test Nick's ability to spell. He did a good job spelling Le Sueur. Reference line is going to be the center line, which is 99% of the cases. Our reference line will be the center line. He's putting his initials to indicate he's the person doing the data collection, and he's putting 2 because we're testing the second lift. You can actually see along the side of the road that we're on the second lift. Now he's going to press save, and we're ready to go into the actual field collection. So this next stage, you want to make sure that your sensors have the correct position, and it's all relative to the center sensor, because our sensor 312 on the left is 1.5 feet to the left of our center sensor. Nick put in 1.5 for the position. Similarly for sensor 305, he put in 1.5 feet because we have 18-inch spacing, or 1.5 feet between our sensors. So we're now in measurement type field measurement, but the first pass of the day, we want to make sure there's no bias between our sensors. So he's selecting quality assurance, and collect mode, you can either select that now or later, which is distance, because we're going to be doing a swerve test. And he's going to also indicate his starting station number, which can be found on the stakes, or he's actually got the alignment file input into his GPS. So he's at station 70 plus 00, and that's why he has starting station 70 and starting station distance 0. We're going in the increasing station direction, so he has the decreasing distance unchecked. He's ready to input his lane. We are in the westbound lane, so he's putting WB. He's ready to put his offset from reference line. Because we're doing a swerve quality assurance, he put 25. And cart position relative to the reference line, this is to the left when looking up station, so he's indicated left in his cart position relative to reference line. We're now ready to indicate our lot. For MnDOT, go ahead, Nick, and put it in. For MnDOT, we're putting a 6-digit or 8-digit month, day, year indication, then a dash, then our route, which is TH60. Then we're putting in the type of pavement, which is HMA, dash, then our lift, which is L2 since it's second lift. Then we're putting in our left extent of the lane we're testing, which is a 12-foot lane to the left of Centerline, dash right extent, which is the Centerline, so he's putting dash CL. And this is mostly because we're processing the data in Veda, and this allows Veda to parse which lane was being collected and which lift, as well as the date and route. And this comes in handy for filtering the data. You'll notice that this is kind of a long thing to be typing in. The good news is it saves it, and you only have to modify it if you change which lane you're in or which lift you're in once you get going. One thing we do here, because we want the file name also to be the same, and this is for similar purposes, is you can actually hold down, if I do this correctly, and then select your lot, copy it, and then go into your file name, hold down, and paste it. And that's a way to, because it's redundant, to repeat that same operation without having to type it. One thing we want to stress here is that when you do your quality assurance measurement, please press or select the include with field measurements, because this allows you to also use this data as part of your MAT assessment when you're doing your assessment of the actual density. What we're using it for right now in the field is to make sure we have no bias between our sensors. So go ahead and press collect, Nick. After a short warm-up period here, you'll see that we're ready to go into our measurement method, which in this case is a swerve. And go ahead and press 500 feet to indicate that we're going to go 500 feet. What you see now is that once Nick presses any of the three sensors here, go ahead, Nick, you now have an indication that says you're collecting data. So now this is going to continue to populate orange until you've reached your 500-foot measured distance. So you now see that Nick is moving left to right, and what he's doing is trying to keep his passes fairly close together, and he's also trying to make sure that he's getting the full lane width when he goes side to side. Okay, so once Nick has completed the swerve collection, it says collection complete, and this orange indicator, status indicator, is finished. Now you can actually see the readout. Left sensor 5.29, center sensor 5.36, and right sensor 5.34. All three sensors within the 0.08 dielectric of the global median here, so you're in good shape and you have unbiased sensors. Nick is actually going to also conduct a swerve, and we recommend you conduct a swerve on the way back by turning the cart around. So go ahead and do that, Nick. So now Nick has turned the cart around and he's ready to conduct a swerve on the way back. Go ahead, Nick, and run your swerve on the way back. And what Nick is doing here is conducting basically the same test, except now, because he's turned the cart around, the right sensor is now where the left sensor was, and the left sensor is now where the right sensor was. And this ensures that we have a similar coverage for both of our sensors to make sure any perceived bias from the swerve test is not actually due to a higher or lower dielectric within the left or right sections of the lane. So he's just swerving back and forth, and once he gets to about a foot away from the centerline joint, he'll start to swerve back in the other direction. And this gets us our random sample of the mat, and it also tests for bias in our sensors. Now that Nick has completed the swerve on the way back, we can look at the, after collection complete, look at the dielectrics of each sensor. We're at a 5.32, 5.33, and 5.34. So they're all actually quite close, well within the 0.08